More factoring strategies specifically at perfect squares and difference of squares, and you guys have seen these before. A quick introduction to that might look something like this. If you had multiplied x minus 5 times x plus 5, you might remember you get x times x plus 5 minus 5 times x plus 5, x squared plus 5x minus 5x plus 25. And notice that those are going to subtract out, and you end up, and I made a mistake here, you guys, don't let me do that. Right? Minus 25, they subtract out, and you end up with x squared minus 25. As opposed to a perfect square, which is x minus 6 squared, or x minus 6 times x minus 6. X squared minus 6x minus 6x plus 36. Notice that those don't go away. You actually end up doubling that middle term. So you get x squared minus 12x plus 36. And the sooner we can recognize those patterns, the easier this is going to be. Looking to recognize patterns. So a couple things before I actually get you started. I want you to pay attention to the minus sign here. That will automatically factor into a plus or a minus. Notice that if this is a perfect square, if you take the square root of 36, you get 6. If you double 6, you get 12. In this case, negative 12. Okay? This was minus 6, minus 6. If this had been plus, plus, this would have been plus, plus. So start looking for some patterns. Consuelo ran across quadratic equation, 4x squared minus 16, and wondered how it could be factored. She wrote it this way. It says use one of our methods. So I would go ahead and I would factor out the 4. Y equals 4 x squared plus 0x if you want, minus 16 minus 4. That's not true. And now we're looking for factors of negative 4 that add up to 0. And doesn't that have to be both plus 2 and minus 2? So we end up with 4 times x plus 2, x minus 2. What are the key features of the parabola's graph? The x-intercepts are plus or minus 2. The vertex is going to be at a 0, and the y-intercept is going to be at negative 16. So this is also negative 16, since the y-intercept and vertex are going to be the same thing. They're not always that easy, guys. This is the special case, right? This is graph the quadratic function at the right, and you're just going to graph plus or minus 2. Plus or minus 2. Negative 16 is down here someplace. You're going to go up 4 over 1, so from 16 to 12. And that is 16 right there, right? Get that in the wrong place. 12 and over 1, there and there. And we end up with this graph going through here. And those are supposed to be nice, smooth. That's supposed to be a smooth transition. I didn't get a smooth transition either time, but you get the idea. Once again, I would go at this, and you could add the 0x in the middle if you want, but we're looking at factors of negative 9 that add up to 0. So that has to be plus or minus 3. So we know this factors into x plus 3, x minus 3. your turn for number 3. Go ahead and pause the video and let it happen. All right, so hopefully you got that answer. Then they asked us, what is the generic rule? Well, we know we're taking the A values, and then the B values are going to be here and here. One's going to be plus, one's going to be minus, and you've got a generic factorization. The expression a squared minus b squared is called the difference of squares, clearly. Good name for it. One of the other special cases is called a perfect square, which we've already seen, right? Now notice one of the things I'm trying to get you to look at is the square root of 9 is 3. If you double 3, you're going to get 6. I know this is a perfect square just by looking at it. So let's do this anyway with a basic factorization. We're looking at factors of 9 that add up to 6. 1 times 9, 2, no, 3 times 3. It's got to be 3 and 3. These are both positive, so y equals x plus 3 quantity squared. All right, now before I turn you loose on B, notice that that one's minus. In order to get a positive here, it's going to have to be minus negative times negative, which is positive. And look for the factorization. Notice that the square root of 4 is 2. If you double 2, you get 4. In this case, negative 4. All right, your turn. Go ahead and see if you can figure it out. All right, so hopefully you got the right answer. Number 7 asks what are the x-intercepts. Now, this is another lesson down the road, but you guys know that if y goes to 0, right, then x plus 3 has to equal 0. That means in this case x equals negative 3 and negative 3. And you know, how can it be the same thing twice? Or over here, if y goes to 0, x is equal to 2 and 2. So that's a situation where you have your vertex is on the x-axis. Both of these are facing up. We're trying to get you more information than you need right now, but this graph at 2 does something like this. This is what is the difference about the x-intercepts for these two equations. They're different because they have the same value, and therefore the vertex is on the x-axis. All right, so now we are going through and you're going to determine key features. I'm hoping you're at a point now where you trust me and you say, okay, I recognize square root of 9 is 3. 3 doubled is 6, so that means this is going to be 3 and 3. Okay, that means my vertex form is going to be x plus 3 squared plus 0, if you will. X-intercepts are going to be negative 3 and negative 3. The y-intercept is going to be 9. That goes back up here to the original equation, right? When x's go to 0, what's left? The vertex we know is at negative 3 comma 0. So this makes it a whole lot easier to graph. Up 1 over 1, up 1 over 1. 9 was up here. That means this is going to be at 9. You know that that's all symmetrical. And these graphs hopefully are getting easier as you go. I'm going to have you stop the video and do number 9. Okay, so again, negative 2, plus 0 means it's not shifting up. You got your x-intercepts, you got your y-intercept. Remember when x's go to 0, your vertex is here. You got 5 quick points, up 1 over 1, because this leading coefficient is 1. The y-intercept was 4, so this is symmetrical about that. And hopefully this is getting easier. Those were both perfect squares you're trying to point out. They said for number 11, let's look at a couple different perfect squares that have a not equal to 1. This is kind of interesting. So we're still going to go through that process. I'm going to have you um, factor this normally and see if you can find some patterns. Okay, so again, hopefully you didn't have any problem factoring that. Is there a way that you could jump straight to here? Do you recognize the perfect square? Factors of 4 that add up to 4. Oh, everything here is a perfect square. Is that true here? Is everything here a perfect square? In other words, in the pattern, did you see that we're looking at factors of 36 that add up to 12? Well, the square root of 36 was 6, doubled is 12. So you're going to, this, if you're doing this a long way, is 6 and 6, or y equals 3x plus 2 quantity squared. Does that work? If you need to, stop the video, verify your solutions to see if you can recognize and see the patterns. It's important that you're beginning to see the patterns. And then they go through the whole process of graphing again. I'm not going to go through the graphing with you on that. You've got a whole bunch of practice problems here that I'm not sure we need to do a lot of. Let's pick a couple and work them. This one, straightforward, that's a perfect square. Half of that is, or the square root of 100 is 10. 10 doubled is 20. So x minus 10 squared. Hopefully that makes some sense. Number 19, we're looking at this. We're looking at factors of 64 times 9. Now, those are both perfect squares. The square roots of those are going to be 3, 3, and 8. 3 and 8 is 24. If you double 3 and 8, you get 48. If you recognize that, if you recognize the pattern, then you simply could go, this is going to be 8x plus 3 squared. And you're literally just taking the square roots of them. A lot of good practice problems here. I don't know if we need to do any more. Oh yeah, let's remind ourselves about differences of squares. Remember, this is going to factor into x minus 2, x plus 2. 24 is also a difference of squares. This is going to go 2x minus 3, 2x plus 3, and so on. Perfect squares and differences of squares, you guys are going to need to spend some time analyzing what you're doing here and figuring out what the process is, more than trying to get the homework done. Figure it out, please.